Hello everyone. Now in this class we are discussing deleting a node from end of the linked list. In previous class we discussed deleting a node from beginning of the linked list. It is simple concept. We started with the start pointer. From the start pointer contains address of the first node. We have to remove that particular node from the given linked list, and we deleted whatever the content which are stored in the first node. Those are going to be deleted with help of deleting from the beginning of the linked list. Now in this class we are discussing deleting a node from end of the linked list. Deleting a node from end of the linked list. In this algorithm, which consists of 7 different steps. Those are step 1 start, step 2 P2 equal to start. It is actual start of the algorithm. It is the content of start pointer is assigning to element 2 more pointer I am utilizing in this algorithm. Those are P1 and P2. I am using 2 different pointers. Those are P1 and P2. For P2 I am assigning start pointer. Content of start pointer should be assigned to P2. Step 3, while length of P2 is not equal to null. While length of P is not equal to null, P1 equal to P2, P2 equal to length of P2, end of while. Step 4, print data of P2, the node which I want to deleting. Before going to be deleting, just I am going to be printing content of that particular node. Step 5, length of P1 equal to null, means the whatever the node which we are freeing. After that, the previous node should become the last node of that linked list. For that, I am assigning that length of P1 equal to null value. Step 6, free P2, whatever the node which I am deleting, that is P2. Step 7, stop. These are the 7 different steps with help of we are deleting a node from the linked list. Just I am going to be visualizing how we are going to be deleting that node. I took a linked list with 3 different nodes. Those are node 1, node 2, node 3. These contains data element 10, 20, 30. In this algorithm, we are deleting a node from end of the linked list. I want to delete a node which is last node of that linked list. If we want to delete the last node of that linked list, for that we are maintaining 2 different pointers, P1 and P2. Why we require these 2 different pointers? Because I need to reach last node. Once you reach the last node, after freeing that node, previous node we have to assign its linked part as a null value. Linked part as a null value. For that, from the beginning, I need to start traversing from beginning to the last node. Because how to identify last node? It is simple concept. The node which contains address value as a null or address pointer as a null value, that node is treated as a last node of that linked list. So if you want to delete last node, simply I need to check all these node address value as a null value. If first node contains address value as a null, then it is going to be a last node. If it is not containing null value, then I need to move to the next node. Once I move to the next node, once again I am going to be checking address of link part of that node. If link part of that node is null, then it will be the last node of that linked list. If it is not null value, then I need to traverse to the another node, or I need to move to the next node. It is how we are going to be traversing in the linked list. Once I reach the end of the linked list, what I need to do is I need to free this node. Once I am freeing this node, what I have to do is I need to update previous node link value as a null. Link value as a null. Because seeing singly linked list, last node address value or link part contains null value. Link part contains null value. Once you are deleting, I need to update previous node link part as a null. Link part as a null. That is the concept we are using in this algorithm. Now I am going to be discussing this algorithm with step by step. Now we are going to discuss this algorithm with an example of considering these three different nodes, how we are deleting a node or last node from the given linked list. We are going to trace out from the beginning of this algorithm. Step 1 start, step 2 p2 equal to start, whatever the content of the start pointer is assigned to a variable or pointer value p2. Now I am assigning p2 equal to 110, p2 equal to 110. The content of start pointer is assigned to pointer p2. While length of p2 is not equal to null. p2 contains a memory location of a node. Memory location of a node that is 110. In this memory location, we are having a node. That node consists of two different parts. Those are data part, link part. Now, what I need to check is I need to check the link part of p2 whether it is equal, not equal to null or not. I need to check these conditions. That is, link part of p2 is 215. 215 is not equal to null. Is not equal to null. Yes, condition 2, 215 is not equal to null. Once this condition becomes true, I need to execute these two different steps. What are those? Because I need to traverse this linked list till the last node of that linked list. For that, I need to perform a traversing. So, in further step, what I am performing, the content of P2 will be assigned to an P1. Now, what I am performing, I am taking in one more pointer value, that is P1. For this pointer value, I am assigning 110 to a P1. I am storing the value of 110, the memory address of a node. First node will be stored to a pointer P1. Now, in this second step, what I am performing, P2 equal to link of P2. P2 equal to link of P2. Link of P2 is a P2 value, 110. Link of P2 is 215. Now what I am performing? I am assigning 215 to a P2. 215 to a P2. It is the first iteration. Just I visited the first node and I checked whether the link part of that node is null or not. If it is null, then it is the last node. If it is not null, then I need to proceed further. Now, what is P2 value? P2 value is 215. Now, it is going to be once again begin with an value, that is link of P2. That is link of P2 is now link of P2 value is 215. Link of P2 is 150. 150 is not equal to null. Yes, condition becomes true. 150 is not equal to null. Then it is going to be enter equal to. Then what is performing? Now P1 equal to P2. What is the P2 value? P2 value is 215. P2 value is 215. Next, P2 equal to link of P2. P2 equal to link of P2. What is P2 value? P2 value is 215. The link value of 215 is 150. 150 is assigned to P2. Now we will move to the third step, third iteration. Now what is the P2 value? Now P2 value is 150. Once again, we begin with an link part of 150. Link part of 150 is null. Link part of 150 is null. Is not equal to null. Now condition become false. Null is equal to null. You need to remember what I am performing is I am considering the link part of P2. Link part of P2 is not equal to null. Now P2 value is 150. P2 value is 150 means link part of 150 is null. Null is not equal to null. Condition become false. Null is equal to null. Once this condition become false, it come out from the loop. It does not execute these two different steps. because it finds out the last node of that linked list. Then what I need to do is I need to print content of that last node and delete that node from the given linked list. Before deleting, what I need to do is whatever the node which I listed earlier, for that linked part I need to assign null value. See here what I am performing. If this condition becomes false, and it is going to be ending of value. After that, printing data part of P2. Printing the data part of P2 is, now I just printed 30. I printed 30. Now link of P1 equal to null. Link of P1. Link of P1. P1 is 215. It is the last changes which we have made. Now P1 value is 215. Now what I need to do is P1 link of P1 equal to null. Link of P1 is now 215. Link part of 215, for that what I need to do is I need to assign a null value. Means for the previous node 215, for its link part, what I need to do is I need to add null value. Once I assign a null value, after that I am freeing node P2 from the given linked list. Means I am dislinking the link between this node, this linked list, which means that I removed this node from the linked list. The last step is step 7, stop. Step 7, stop. It is how we are deleting last node of the linked list.